All right, so how to solve rational equations containing variables in the denominator. All right, so step one, remember what we did last time? We factored the denominator, so that's step one. So step one is to factor the denominator of each rational expression. Now remember, the other thing we did was once we factored the denominators, then we found the restrictions. So remember, the restrictions is what value of the variable makes the denominator 0. Then once you do that, the third thing we did was we found the LCD. Then the fourth thing we did was we multiplied both sides by the LCD, and the purpose of that was to clear the fractions. And then we solved the resulting equations, and then today we need to talk about extraneous solutions. So that was one of the things that we never came upon last time. We always had a solution that was not one of the restrictions. So today we're going to look at that kind. And then you'll be able to do the problems that's on the back page of the worksheets I gave you. All right, so let's look at a problem that deals with this. Okay. So you weren't able to see anything up there? Y'all didn't say anything. All right. Okay, so number one. So we're going to solve these rational equations, continue on solving rational equations. Okay, number one, we have 18 divided by x squared minus 3x minus 6 divided by x minus 3 equal 5 divided by x. So 18 divided by x squared minus 3x minus 6 divided by x minus 3 equal 5 divided by x. All right, so no, that's 1.2. We're still trying to finish up 1.2. Okay, so we have this rational equation. There are variables in the denominator. What's step one?
Finding LCD.
Not yet. What's step one? The first step is not to find the LCD first. What's the first step?
Back to the denominator.
Yeah, guys, I gave you this sheet. Only one person said what's on this sheet. So you factor the denominator. All right, so this x squared minus 3x from last semester, how do you factor that?
Take out the common.
Take out a common factor, the GCF. What's the GCF?
X.
X. So this becomes x times x minus 3. That's how you factor this. And you can always check yourself, because if you distribute, what's x times x? X squared, and x times a negative 3 is a negative 3x. All right, now if you look at the second denominator, x minus 3, can I factor that?
No.
No. Okay? And this is just a monomial. I can't factor the monomial. Leave the monomials alone. So now we're going to talk about our factors. In this denominator, how many factors do you see? You need to know what your factors are from last semester. How many factors do you see? What are the factors? X, and what's the other factor?
3.
X minus 3. Remember, factors are products. It's kind of like saying, if I have the number 8 and I say that 8 is 4 times 2, right?
Right.
The factors of 8 that I have, 4 is a factor, and what else is a factor? 2. So I wrote this polynomial as a product. Each of those things that are being multiplied together is a factor. So my factors are x. What's the other factor? X minus 3. What's the factor over here? X minus 3. What's the factor over here? X. So remember, the whole purpose of multiplying both sides by the LCD is to clear the fractions. So here's the idea. If I want to get rid of this x right here, then I also have to multiply this fraction by what? X. So we'll divide out. If I want to get rid of x minus 3, I also have to multiply by what? X minus 3. Same thing here. Same thing here. So when you're finding your LCD, it's not very difficult to find the LCD. Your LCD has to include every factor. So what's my first factor? X. I need it. What's my other factor? I need it. What's my next factor? X minus 3. I already have it, right? What's my other factor? I already have it. So there's your LCD. Once you find your LCD, then we're going to multiply both sides by this LCD. So I'm going to go ahead and rewrite this over using this, though. That's factored. So I have 18 divided by x times x minus 3 minus 6 divided by x minus 3 equal 5 over x. All right, I just rewrote the problem with the denominators factored. All right, so we're still on part 1. Keep that in mind. We're still in part 1. Now, part 2 says, since I have variables in the denominator, I have to find my restrictions. All right, you have to find your restrictions. So let's talk about the restrictions. The restrictions are the values of x that makes my denominator 0. So, for example, if I look at this denominator right here, what makes this denominator 0? Because remember, you can't divide by 0. So what makes it 0? 3, when x is 3. So right now, I know that I cannot use 3. So 3 would be one of my restrictions. Over here, what makes this denominator 0? 0. So I have how many restrictions so far? 2. Now I got to go to this denominator. Well, your factors, just look at your factors. What factor am I pointing to right now? X? Didn't we already talk about it? What makes this 0 right here? 0. What makes this 0? 3. I already have them. So how many restrictions are there? 2. All right, so that was step 2. Step 3 is now to find the LCD, which I already did. So we did step 3 already. Step 4 now is to multiply both sides by the LCD, which means, though, if you recall last time, when you multiply both sides by the LCD, I'm just going to show you. You can skip this step right here, but basically you're going to multiply this side by the LCD and this side by the LCD, because remember, what you do to one side, you have to do to the other. But then notice I did introduce parentheses, right? So now to get rid of the parentheses, what property did you learn in the past that allows you to do that? Distributive property. So you're going to multiply all parts by the LCD. So if you want to, you can go from the original, from this step here to this, and here's what you're going to write. You're going to say the LCD times the first fraction minus the LCD times the second fraction, and then the LCD times the other fraction. See what I did? Okay, so that was what step 4 says. So step 4 says you're going to eliminate all fractions by multiplying all terms by the LCD. And this will make the denominator factor 1. That's what we talked about last time. You want that denominator to be 1. And it will now be 1, because notice what happens. X into x is 1. X into x is 1. X minus 3 into x minus 3 is 1. X minus 3 x minus 3 is 1. Over here, what's the only thing I can reduce in this part right here that I'm circling? X minus 3. That's the only thing. What's the only thing I can reduce in this part here? X. And notice, now just don't cross it out. Make sure you put a 1 there like I did. Because you have to understand, well, why am I crossing it out? What really is there? Well, what's there is the number 1, a factor of 1. So now what you have is this. You have 1 times what? What is this right here? So what is this right here? 18. Minus. Here you have x times 1 times 6, which is what? 6x. Equal. Over here you have what? Now be careful with that one. You have what? 5 times, let's keep it like this for right now. 5 times what? X minus 3. That's what I have. So it's not 5x minus 3. If you want to skip that step, you could. It would be 5x minus what? 15. That's what it would be. All right, so notice, I want you to notice something. I went from a rational equation to what kind of equation? Linear. That's the linear equation. And y'all did that on day one. You actually did that 2 semesters ago and 2 courses ago. How do you solve this equation?
Combine like factors on both.
Before you combine like terms, what do you think you may need to do?
Oh,
Distribute. So I get 18 minus 6x equal 5x minus 15. Now what's the next step? There's no terms I can combine on each side. So what's the next step? Get the variables one side, constants to the other. So let's go ahead and bring the variables to the right-hand side. What do you need? Let's do the variables first. What do I need to do to both sides? Add what? 6x. Good, because right now I'm subtracting 6x. The opposite is to add 6x. And then we do what now? What's that word? Those words? Combine like terms. When I combine over here, that's 0. What's left? 18. Over here, what do I get? 11x minus 15. What's the next step? Add 15 to both sides. And so it's 18 plus 15. 33 equal 11x. Because when I combine these, that's 0 right here. That's a 0. How to get x by itself? Divide both sides by 11. And so I get x to be what? 3. All right, so I get x to be 3. Now notice quite a few steps. Okay, so is that my solution? No, it's not. That's not a solution. We're going to call this right now a proposed solution. Now, you don't write the word proposed solution on a test. I'm just telling you that this is my proposed solution. I'm saying that I think is a solution. But let me think about this a little bit clearer now, right? Because what do I know at some point when I was doing this problem? My restriction is that x cannot be 3. Because if you're saying 3 is a solution, and you go back and you check it, what happens in this denominator right here? Then it becomes 0. Can you say 6 divided by 0? No, that's undefined. So how many proposed solutions did I have? 1. Is it an actual solution to the original problem? No, but let me say this though. Is x equal 3 a solution to this equation right here that I'm pointing to? Yes, it is. Is x equal 3 a solution to this? Yes, it is. If you plug in 3, 33 minus 11 times 3 is 33. 33 minus 15 is what? 18. So then you say, well, why are you saying it's not a solution? Because it's not a solution to the original. It's not a solution to the original. It's a solution to these down here, but it's not a solution to this one. So we call this an extraneous solution. So that's an extraneous solution. So an extraneous solution, think of the word false solution, the idea of a false solution. So an extraneous solution basically means this. It's a solution to an equation that I ended up at some point with, but it's not a solution to which one? The original. It's not a solution to the original. So this is not a solution to the original. Okay? So then you might ask, well, what do I write in the blank that you put? So if I have x equal blank, if I have x equal blank, you're going to say no solution. Now, in my math lab, the symbol you're going to use for that will be this. This right here, which, remember, that's a symbol for the empty set. Okay. All right. So extraneous solutions. Extraneous solution is false solution. It's a solution to one of these equations, but not a solution to the original. So that's what we call it extraneous, a false solution. All right, so that's number 1. Let's look at another one. Let's look at this one. So in this one, let's suppose you have x divided by x plus 4 equals 3 minus 4 divided by x plus 4. All right. What's step one when solving a rational equation?
Factor.
Factor. Can I factor anything that's in those denominators? No. You can't factor x plus 4. X plus 4 is x plus 4. So what's the LCD?
We have to determine the restriction.
X plus 4.
But I could determine the LCD right now, though, if I wanted to, right? But
Oh, yeah.
what's the LCD?
X
X plus 4. Now let's talk about the restrictions. What are the restrictions? X cannot equal what? Negative 4. Because negative 4 plus 4 is 0. All right. So if I solve this equation and I end up with x equal negative 4, x equal negative 4 is called what kind of solution now? Yeah, but it'll be extraneous. And then in the blank you would say what? Since that's the only proposed solution, in the blank you would say what? No solution. Okay, so let's go ahead and do that. So the LCD is x plus 4. So you're going to multiply every fraction by 4, which basically you're multiplying both sides by 4. How many fractions do you see here altogether? No, there's more than 2. 3. There's this one. There's this 3. And then there's this one. So when I multiply every term by the LCD, I'm going to write this one over. Oops. That has to be multiplied by what? X plus 4, the LCD, equal. I'm going to write this one. That has to be multiplied by what? X plus 4. But I'm going to put that in parentheses. And the reason is because this X and the 4 has to both be multiplied by what?
3.
By 3. Minus, and then 4 divided by X plus 4 times what? X plus 4. But notice the reason why I put that X plus 4 in parentheses with the 3. I didn't need any others, although I could have. If you want to put this in parentheses right here, you could. You can if you want to. It does not matter. But it is needed here. Now remember, the whole purpose of multiplying every fraction by the LCD is to get that denominator to be what factor? 1. And now it is. X plus 4 is divided out. What are you left with over here? X equal. Now you got to distribute here, so that becomes 3x plus what? 12. And then over here, what's left? 4. All right, so that's where I'm at. So notice I went from a rational equation to what kind of equation? Linear. All right, what can I do on this side? All right, so what do I get when I do that?
X equals
3x plus 8. Okay, let's bring the 3x to the other side. So what am I going to do? Subtract 3x. So what's x minus 3x? Negative 2x. Combine like terms, this is 0. What's left? 8. What's the next step? Divide by? Yeah, I'm going to go ahead and rewrite this over. And so what do I get for x? Negative 4. Now if you're not careful, you're going to put that in your blank. Now you'll get most of your points, but you're not going to get all of it because you're saying the solution is negative 4, and it's not. Negative 4 is a restriction. So this proposed solution is really an extraneous solution. That's an extraneous solution. So then in the blank, you're going to say x equal what? No solution. Or you can say the empty set. So remember, you got to look for this idea right here, that that's an extraneous solution. Okay? When at some point you're going to solve a rational equation that's going to turn into quadratic. Everyone we've done so far turned it into what kind of equation? Linear. Remember last time we started talking about quadratic? So at some point we're going to do a rational equation that turns into quadratic, and in that case you're going to end up with 2 solutions. One may work, the other one may not. All right, but that'll be a couple of classes from now. All right, let's look at this one.
I have a question.
Yes.
But do you always just use your first number to determine your restriction? Like,
What do you mean the first number?
because like in the last one we used 3. You always
Well, you actually, oh no, she's asking, is it always this number you see? No, because my denominator could have been 2x minus 5. What would you have to do here? Set equal to 0. to find your restrictions. So then you add 5 to both sides, then combine like terms, 2x equals 5, divide by 2, so x is 5/2. So that's your restriction. So basically what you're doing is you're taking this denominator and setting it equal to 0. So yeah, so you say x minus 3 equals 0, so x is 3. So that'll be your restriction. That's a good question, because it's not always going to be a nice binomial with x having a coefficient of 1. It could have been 7x minus 3. So basically you're just taking this denominator and setting it equal to 0 and solving for x.
Yeah.
All right, so let's look at number 3. So number 3, suppose we had 5 divided by p plus 6 minus 1 divided by p squared plus 6p equal 2 divided by p squared plus 6p. So write this down. All right, now, what's our first step to solving this rational equation? Factor. Can I factor that first denominator? No, but can I factor the second? Yes. So how do I factor the second? P times p plus 6. Can I factor the third one? Isn't the same thing, right? You can always check yourself by distributing back. P times p is p squared. P times 6 is 6p. So every factor you see has to be part of the LCD. So let's start with the first one. What's that factor that you see? P plus 6. I'm going to put that in parentheses for right now. Then let's go to the next fraction. What's that factor you see, the first one you see? P. So I need a P in my LCD. What's the next factor you see? I already have it, right? What's the next factor you see? I already have it. What's the next factor? I already have it. So what's your LCD? P times p plus 6. So then you're going to multiply every fraction by that LCD. But before we do that, let's find the restrictions. How many restrictions are there?
2.
2. Because your LCD contain how many factors? 2. One is p, and what's the other? P plus 6. So the restrictions is that p cannot equal, what makes p plus 6 equal to 0 when p is what? Negative 6, good. And then what makes the factor p equal to 0 and p is what? 0. So those are your two restrictions, negative 6 and 0. So if I solve this equation and I end up with my solution, my proposed solution being one of these, then I can't use it. It's an extraneous solution, so then I say no solution. All right, so then the next step, we've got to show the work now. So the next step is to take each of those fractions, multiply by the LCD. Now when you write those fractions though, let me remind you what I want you to do. So your first fraction, you're going to say this, minus your second fraction. Now here's a question. Are you going to write the denominator as p squared plus 6p? No, you're going to write it in that factored form. So what are you going to write it as? P times p plus 6 equal 2 divided by p times p plus 6. Now what do I do to each of those fractions? Multiply by what? LCD, very good. So I get p times p plus 6, p times p plus 6, p times p plus 6. Okay? The next step is to reduce. So the next step is to get all those denominators with what factor? What should end up being in the denominator? 1. That's what should end up being in the denominator. So then you're going to say p plus 6 divided by p plus 6 is 1. Make sure you put 1. Don't just cross them out. Make sure you understand that that's a 1 that goes there. Kind of makes sense because if you look at 8 divided by 8, you just don't cross that out like that because you know that 8 divided by 8 is what? 1. So that's a 1, that's a 1. You end up with 1. So make sure you understand that when you cross it out like that, that's really a factor of 1 that you have. Over here, what can I reduce over here? The p and the what? P plus 6. Over here, what can I reduce? The p and the what? P plus 6. All right, so let's look at what we have. What is this right here that I end up with? 5 what? P. Don't forget the P. You can't see it very well, but that's a P there. Minus, what's this? 1. Equal, what's this? 2. All right. What's the next step?
Get 1 on the side.
Add 1 to both sides. So I get 5P equal what? 3. Then do what? Divide by 5. And so I get P to be 3 over 5. So that's my proposed solution. Is that one of my restrictions? No. So it's going to be a solution. So if I were to take that proposed solution, and I'm not because it's going to take too long, and put it back into the original problem, then the left side should equal the right side. My denominator will never be 0 when P is 3/5. So then on the worksheet, it'll say x equal blank. What are you going to put in the blank? It won't say x, it will say P in this time. P equal what? 3/5. 3/5. Okay, let's do one more. Number 4. All right, number 4. Suppose we had 6 divided by 3x minus 15 minus 3 divided by x plus 5 equal negative 7 divided by x squared minus 25. So 6 divided by 3x minus 15 minus 3 divided by x plus 5 equals negative 7 divided by x squared minus 25. Okay, what kind of equation is this? What kind of equation is this? No. No. It's not quadratic. What kind of equation is this, guys? You need to know the kind of equation in order to be able to solve it. It's a rational equation. It's a rational equation. Now, I understand why some of you are saying quadratic, because you see that x squared, right?
Yeah.
But quadratic equation, if you remember the form, ax squared plus bx plus c equals 0, if you remember that, the variables are not in the denominator. Notice when we did those quadratic equations last time, you never had any variables in the denominator. All right, so whenever you have fractions and the variables in the denominator, then we can automatically say it's what kind of equation? Rational. All right, now what's the next step? Factor. So how do I factor that first denominator?
3.
Factor out of 3, so what's left?
3 times x minus 5.
Okay, can I factor anything else?
The
The last one. Now let's hopefully you remember what that's called. X squared minus 25 is called what kind of factoring? Difference of 2 squares. Okay, good. So how do you factor this? X minus 5 times x plus 5. Very good. That's how you factor the difference of 2 squares. So we did a lot of that last semester. All right, so let's talk about the restrictions now. So let's talk about restrictions. So the restrictions. X cannot equal. All right, let's talk about our factors. What's the first factor I see? 3. Will that ever be 0? No, 3 is always going to be 3. All right, let's look at the next factor. What's the next factor I see? X minus 5. When is that equal to 0? When x is what? 5. So one of my restrictions is 5. Let's go to the next one. When is this 0? Negative 5. I'll go to the next one. When is this 0? When x is 5, I already have it. When is this 0? Negative 5, I already have it. So how many restrictions are there? 2. All right. Now let's talk about the LCD. Your LCD has to include every factor. What's the first factor you see? 3. What's the next factor you see? X minus 5. What's the next factor you see that's not already listed? X plus 5. And then all these are already listed, right? All right. So your LCD has how many factors? 3. 3, X minus 5, and X plus 5. The ones we did earlier, there are only 2 factors. Now we have one with 3, but it's still the same thing. It's just as it's not as difficult as the others. How many fractions did this equation have altogether? 3. So I'm going to list them. And when I list the denominator, don't rewrite it as 3x minus 15. Rewrite it as in factored form so you can reduce. So it's going to be 3 times x minus 5. Leave some space, and this is going to be 3 divided by x plus 5. Leave some space, and that's going to be negative 7 divided by, and what are you going to write in the denominator? X minus 5 times x plus 5. And you could have said x plus 5 times x minus 5. Does not matter. Multiplication is commutative. The order in which you multiply does not matter. Okay, so all I did was I rewrote the problem with the factored denominators. What's the next step? Multiply all these fractions by what? The LCD. So 3 times x minus 5 times x plus 5. 3 times x minus 5 times x plus 5. 3 times x minus 5 times x plus 5. Just like that. So every fraction has to be multiplied by the LCD. Now remember, the purpose of multiplying by the LCD is to get that denominator to be a factor of what? 1. So if I'm doing this correctly, I should now get a factor of 1 when I reduce. Because notice, down here in the denominator, I have a factor of 3. Does that reduce now?
Yes.
Yes. I have an x minus 5. Does that reduce now? Yes. Okay, let's go to the next one. I have an x plus 5. Did that reduce?
Yes.
Yes. I'll go to the next one. The x minus 5. Does that reduce?
Yes.
Yes. X plus 5. Does that reduce?
Yes.
Yes. So all I did at this point, and that's what you need to do at this point, is to go in and reduce your common factors. All right, now, let's talk about what we have left. The first one, you got to be careful with, as well the second one, I guess. But the first one, do you see that's a 1 times x times 1 times x plus 5 times what? 6. Try not to do too much in your head right now. Just write it out. That's really going to be 6 times what? X plus 5 in parentheses. Okay? Minus. Now be careful. Let's talk about what we have left. We have a 3 times x minus 5 times 1 times what? 3. So how do you think I may want to rewrite this right now?
3 times 5x.
3 times 3.
I'm hoping someone would have said something else. 9. 9. 3 times 3 is 9. So that's really 9 times what in parentheses? X minus 5. Remember, we just said multiplication is commutative. The order in which you multiply does not matter. So if you have some constants, well, these are not really constants, but you have coefficients. If you have factors, let me rephrase it. If you have factors that are whole numbers, then multiply them. 3 times 3 is 9. Now, using that idea, let's look at the other side. 3 times 1 times 1 times a negative 7. What do you think you may want to write? Negative 21 times what? Oh, that's it, right? So that's negative 21. It's just negative 21, right? 3 times 1 times 1 times negative 7 is just negative 21. Okay? So that's where we're at. All right. Now, notice if you're not careful, you could have easily made a mistake anywhere in that process. So you need to be very careful. So the worksheets is what you use to find out what your errors are, and then don't do those errors on the test. Yes?
Now, the negative in front of the 9, is that with 9? Or
Yeah, just distribute the negative 9.
Okay.
Yeah. So over here, to get rid of the parentheses, I use what property? What property do you use to get rid of the parentheses? Distributive. So this one's easy. I'm going to distribute the 6. Here, distribute the 9 or negative 9? Negative 9. All right, so what's 6 times x? What's 6 times 5? Okay, what do I get over here? Minus 9x, and then what? Plus 45 equal a negative 21. So notice I went from a rational equation, and what kind of equation is this? Linear. All right, look at what you have and think about all the years that you've solved linear equations. What's the next step? Combine like terms. So let's do with the variables first. What's 6x and a negative 9x? Okay. What's 30 and a 45?
75.
Equal? All right. What's the next step? Combine like terms. I get negative 3x equal negative 96. What's the next step? Divide both sides by negative 3. And I get x to be what? No, a negative divided by negative is a positive. So positive 32. Okay. So this proposed solution, is that really a solution or is that an extraneous solution? It's a solution. It's a real solution. Okay. So on this worksheet you would say solution, then you say x equal, what do you put in the blank? 32. Okay. All right. So we did 4 problems with rational equations. 2 of those involved extraneous solutions. 2 did not. Okay. Notice that in each of those you follow these steps. You did each of those steps. If you go back and you look at it, we did each of those steps. Okay. All right. So let's see.